Hello, I'm Papia. In this problem, we have to show u and v are equivalent, where u and v, they represent directed line segments from the first point to the second point. So how do we show two directed line segments are equivalent? We can show that by showing that those line segments have the same length and same direction. So let's start by showing that they have same length. Okay, so let's start with u. How do we show that they have same length? How do we find the length of u? Well, notice that it's a line segment between these 2 points. So the length of u is just the distance between the 2 points. So we have to use distance formula and compute the length. Okay, so recall the distance formula is square root of, you take the difference of the x values, square that, so 5 minus 3 square, plus you take the difference of the y values and square that, so 6 minus 2 square. Okay, let's simplify that. 5 minus 3, that's 2 square, plus 6 minus 2, that is 4 square. So this is square root of 4 plus 16, which is square root of 20. So square root of 20 is the length of the line segment u. Let's do the same for v. Okay, so we use distance formula again. Now look, the difference of the x values for v is 3 minus 1 square, and then difference of the y values are going to be 8 minus 4. Square that. Simplify, 3 minus 1 is 2, so this is 2 square, plus 8 minus 4 is 4, so we have 4 square. Okay, we get square root of 4 plus 16, and as you can see, this will also be square root of 20. So since both of them have same length, we have just proved that u and v, they both have the same length. Okay, now we have to show that they have same direction. To check that they have same direction, let's first plot the line segments, and then we can see the direction from the graph. And we can also figure out if they actually lie on parallel lines or not. Okay, so let's come here. Recall that the points that u goes from the first point and the second point are between 3, 2 and 5, 6. And v is between 1, 4 and 3, 8. Okay, so let's plot them. For u, first point is 3, 2, starts here, ends at 5, 6. So approximately right here. So u is this directed line segment. Similarly, for v, let's plot 1, 4, that's the starting point, and it ends at 3, 8. About here. Okay, so this line segment is v. Now you can tell from the graph, they look like they are directed in the same direction, but just check in case there is some kind of mistake here. So how do we check that they both lie on parallel lines? That's what we have to check, right? Well, parallel lines have same slope. So why don't we find the slope of both lines and see if they're same or not. Okay, in order to compute slope of a line, you need 2 points. And notice that we have both points, both for u and for v. So let's compute slope for u. And by that I mean that we are finding the slope of the line on which u is lying. Okay, how do we compute slope? It's the difference of y values divided by difference of x values. So the difference of y values for u is going to be 6 minus 2 divided by difference of x values is 5 minus 3. And this is 6 minus 2 is 4 divided by 5 minus 3, that's 2. So the slope is 2. Okay, let's find slope for v. Same thing, difference of y divided by difference of x. For v, we have 8 minus 4 in the numerator and 3 minus 1 in the denominator. And that is 4 divided by 2, which is 2. So we see that they have same slope, and therefore those two lines are parallel, which means u and v, they both have same direction. Another way of showing that u and v are equivalent will be to figure out the component form of both u and v. So we can just look at u and write down the component form for u. So let's do that. So what is the component form for u? You know, we write it inside this type of bracket, and it is, you take the difference of the x values, that's the first coordinate, so 5 minus 3, and then the difference of the y values, that's the second coordinate, so 6 minus 2. And that is equal to 2, 4. So this is the component form for u. Okay, let's do the same for v. Well, we do the same thing. Difference of the x values is the first coordinate, so this is 3 minus 1, and difference of y will be 8 minus 4. And notice that the first coordinate is 2, the second one is 4, which means u and v, they have the same component form, which also tells you that they are equivalent. So there are two different ways you can show u and v are equivalent. Thank you.